In this video, we have a function f of x, which has a domain of -4 to 6, with the -4 being included, and a range of -infinity to 3, with the 3 being included. What is the range of the function g of x equals -2 f of x minus 4? And we are actually going to do with range and domain. There we go. Because I just forgot to type the one. So to start off with, I'm going to go ahead and do the same thing and use transformations here. So looking at my actual function, we're going to start off by writing the transformations. Inside affects the x values in the opposite way. I have x minus 4 inside, which means we're really going to do x plus 4. And then outside affects the y values in the same way. We have a -2 there, so y, actually it's not -2, sorry. It is -2 times f of x, so it's going to be y times -2. Based on the order and how it's connected, it's considered -2 instead of -2. So there we have our transformations. Now we just have to use them on domain and range. So currently the domain is -4 to 6, -4 being included, and the range is -infinity to 3. However, we can apply transformations to this to figure out the new transformed range. Starting with x, our rule is x plus 4. So I'm going to add 4 to each of my endpoints for the domain. So -4 plus 4 is 0, still included, and 6 plus 4 is 10, which is not included. So there is that. For range, we'll do the same thing. I'm going to multiply each endpoint by -2. So -infinity times -2. Now normally multiplying by 2 would not do anything to the infinity, because massive number times 2 is still that massive number. However, because we're doing a negative times a negative, it's going to turn it into positive infinity. And then -2 times 3 would be -6. We do have one issue with this. This is not acceptable. When you're using interval notation, the smaller number has to come first. So we need to rewrite it as -6, comma, infinity. I just realized I did not put the square bracket with the 3. So square bracket there. Square bracket with 6. And then whenever I change it around, square bracket, parenthesis. There we have it. We have our domain of the transform function, and we have our range. In this video, we're supposed to describe transformations of f of x, which combine to form g of x, which is negative f of, in parentheses, we have x plus 4, and outside we have -3. Going through, let's write out the transformation rule first. So inside affects x and opposite. Stuff I see on the inside is x plus 4, which means we're going to do x minus 4. For outside, affects y and same. We have two things on the outside. We have the negative sign in front, which means we have times -1. And then we also have the -3. For the outside stuff, order of operations as follows. So we're going to take y and multiply by -1, and then subtract 3. Now that we have that, we can go ahead and describe the transformations. I'm going to start with translations. Translations are caused by addition and subtraction. I have addition and subtraction with x, so we're going to translate 4 units. And if I subtract 4 from the x values, that's going to move in the left direction. We also have addition and subtraction with the y values. We're subtracting 3, so, and 3 units. Since we're subtracting 3, it's going to be 3 units down. We have one more thing going on. We're multiplying by -1. Multiplying by a 1, a value of 1, doesn't actually do a dilation. However, multiplying by a -1 creates a reflection. And to be precise, it's reflected across the x-axis. It is reflected across the opposite axis from the values it affects. So if it affects y values, it reflects across the x-axis. There we have it. So describe the transformations of f of x equals the absolute value x to form the combined, which combine to form the function g of x graphed below. So in order to do this, you do have to know what the parent function absolute value of x looks like. These were the 3 points we used to help us graph it. So this is what the parent function looks like. Of course, it runs off the side. So I'm going to start with translations. Because I can tell it's not on the same point. So for translations, I'm going to focus on the vertex. You can see that it translates down 1 and 1, 2 to the left. So that's my translations. There is no reflection. It's still a V shape going up in the upwards direction. So no reflections. But it does look like there's a dilation because it's no longer as fat as of a V shape that it was. So it dilated. And if you look, normally absolute value goes over 1 and up 1. This is going over 1 and up 3. So dilated vertically by a factor of 3. You can also write it as a horizontal dilation by a factor of 1/3. But usually, if it can be done, describe it vertically. There we have it. In this video, we're describing the transformations of the function f of x equal to the absolute value of x, which combine to form g of x, which is 2 times the absolute value of x minus 1. So just going through writing out my rule first. Inside affects x and opposite. I see x minus 1 inside, so we're really going to do x plus 1. Outside affects y and same. I see a times 2 on the outside, so I'm going to do y times 2 as my rules. Now that I have that, I'm going to describe the transformations. I like to start with translations, so we are translating. We only have one addition subtraction, so we're translating 1 unit. And if we add 1 to x, that is going to move it to the right. For the y rule, it's y times 2, so that's going to be a dilation and not a translation. So dilated vertically by a factor of 2. And you can get more precise. Instead of just saying dilated vertically, you could say stretched. Because what you multiplied by is bigger than 1.